Last thing before we begin, please interrupt me. If there are any questions or comments, just raise your hands and let's get those sorted out of the way. So I'm Nejc. I run a Python web company called Untitled for the last 10 years. What we do nowadays is mostly we build software as a service products, and in spring we sold the majority of them, kept just one who was the most profitable one, and then for the last 6 months I've been on kind of a saga to figure out what's the next big thing in IT, in computing, so that our company survives for the next decade. And just in these few months, my mind has completely been blown by deep learning. So who here has heard about deep learning? That's basically everybody. That's good, because besides sounding like a buzzword, I think it has the potential to be as big of a paradigm change as the internet was, maybe even bigger. Welcome. Does anybody remember this Gmail autopilot? That was from 2009. Gmail got an autopilot, so it would basically write your emails for you. It was an April Fool's joke. So, there was 10 years ago, the computers, we all joke that computers are stupid, and we joke so much about how computers are stupid, we'll make jokes like this, April Fool's joke that computer will never be as smart as to write your emails. But then this happens. What was this? Months ago, Gmail actually got a smart reply, which is it will read your email and propose 3 replies, which is kind of getting close to replying to your emails. So maybe the joke's on us, or at least will be. Another example is the Babelfish from the Hitchhiker's Guide to the Galaxy. It was a fish that will translate from any language into any language, and because this is such a complex task that technology will never solve, or evolution will never solve, it proves the existence of God. Also disproves it, but yeah, philosophical things. Again, then this happens.
What do you think of these cool new headphones?
Vad tycker du om de här coola nya hörlurarna?
Mitt team designade dem, så jag tycker de är ganska coola.
So those of you that don't hear, it's actually on-the-fly speech translation from English to Swedish and then back. Kind of getting close to the Babelfish, and it's rudimentary nowadays, but give it a couple more years and we're going to be there. But surely art is still fully in the domain of humans, right? In this past year, I was traveling around to a couple of museums, and let's do a quick show of hands. How many of these were made by a computer? 1? 2? Yeah? 3? You think all of them were made by a computer?
Yeah.
Well, yeah, you're right. This is called style transfer. Basically, you take an image and then you apply the style of another image, and you get this funky new art. We also have now music generation by deep learning algorithms. So computers are also moving into art. If you go to deepart.io, you can play with this on your own. But why now? We've been talking about AI for decades, and we've had the first AI winter, and we had the second AI winter, where there was a huge hype and then just nothing happened. Why is this different? Why is this time different? Well, first, to have smart computers, what you need is you need an infinitely flexible function, meaning a function that can describe anything. Either this is image style translation or translating from one language to another. And we have that. That's the neural networks can do that. But neural networks have been with us for years, so we've had that for decades. The second one is a all-purpose parameter fitting procedure, and only recently data scientists have realized that the most basic gradient descent that everybody here had to know in high school, when you apply it to a multidimensional space, it's enough. It's never going to go into a local minimum because you have so many dimensions. You just run it over and over, and you get better and better. And then the second one is backpropagation, which allows you this gradient descent to be even faster. So these are the basically old technologies or principles that we have realized that we can apply to neural networks only recently. And the third, which is actually the most recent, is it needs to be fast and scalable. And the gaming industry is huge. And what games are computing how the light projects for each pixel on your screen. So that means a ton of parallel operations every few milliseconds. And the gaming industry, being as huge as it is, dumped loads of money into getting cheap but very performant video cards. And it turns out that neural networks are linear algebra, doing a lot of matrix operations, which is exactly what rendering a video game is. So we got this insanely cheap and insanely fast graphics cards that we can buy for a couple $100, and they're like several orders of magnitude faster than our CPUs. So these three combined is the reason why I believe an AI revolution is really imminent. And it's not that that's just my opinion. Google had, back in 2012, they set up a team that would go around Google, like a team of data scientists, the team that knew how to do AI, the team that knew how to do deep learning. They went around Google and then taught different teams how to do it. And then this is the graph of how many teams or how many products inside Google use deep learning. And you can see this like perfect hockey stick, meaning that like sooner or later all the teams in Google will use deep learning. It's not just Google.
Do you think of Amazon as an artificial intelligence company now?
Oh, for sure. Everything we do, and I say this to my teams all the time, if you're not thinking about machine learning in every aspect of what you're building on behalf of customers, we're probably making a mistake.
Let me iterate that. In Amazon, if you're a developer and you're not thinking about machine learning, which deep learning is a subset of, in everything you do, you're making a mistake. So, I think we should all do it. But isn't machine learning the domain of math scientists? Or don't you need a dual PhD in math and probably physics to be able to do deep learning? The last time I heard, machine learning is all about big data. You need huge amounts of data to train a neural network. And this talk is to show you that no, those are both false myths around deep learning. One of the scientists that have been working on deep learning in the recent years have actually started to publish not just their papers and like formulas and Greek letters all around, but actual libraries that you can download and use, like open source libraries. And you basically just need to find them, read the README, and then start using them. So for me, it's basically like Zope. Is Hano here? No. So nobody in this room knows how Zope works, but we all use it, right? You've learned to treat it as a black box, and you have to treat it in exactly the right way, and then it sort of works, and everybody's happy. So maybe you treat deep learning as such. You have to just learn how to use it. You don't need to understand everything that goes underneath. Another thing is maybe I think this is kind of like JavaScript, Not all of us love JavaScript, but if you're a developer these days, you just have to know JavaScript. And I think in coming years, not everybody will be a deep learning expert, but at least everybody will have to have at least the basic understanding of what is out there and how to use it. And the third reason, the third thing is I've tried to go into machine learning years back, and I just completely failed. There was a Coursera course and a Udacity course, and maybe I did one lesson, which is Greek letters all around. It was like meant for math majors going into computer science, so I just failed. And everything was in R and Lua, which for me is just, I didn't have time or energy. But nowadays, everything is moving to Python. And, Keras is one of the friendliest machine learning libraries out there. It's written in Python. You pip install it, and you can start using it. So with that, let's pray to the gods of live demo.
Is that the goal of live demo?
What?
It's the idea.
adjust my, let's see. Do we see this? We do. Okay. So being fast and scalable, one of that approach is also usability. So if you want to start doing deep learning, you can do it on a computer. It's probably going to be slow, but we have Amazon. And Amazon now ships or provides virtual instances with an integrated graphics card. They're not cheap. They're about, I think they're 90 cents per hour, sorry. But then you can just, you can start it, train your model, and then stop it, and then use the model on with your CPU. That's perfectly fine. The training is the thing that is resource intensive. So this is what I've done here. I've spin up a G2 extra large instance. Let's see, I'm going to copy this IP. Okay. So the first thing we're going to do is, let's see of what we're going to do. So this is an image of our dog. She's called Pia. And we're going to ask the computer, is this a dog or is this a cat? Okay, 5 years ago doing this would require feature engineering. You need to have a team of a data scientist or a machine learning expert, and then maybe a data analyst that will prepare a lot of images. But we're going to train the computer to decide if this is a dog or cat with around 2,000 images, and in under 2 minutes. At least that's the idea. So the images we're going to use are just some images of cats and some images of dogs. Okay, so we have a training folder, which are the images used for training, and we have the validate folder, which is the folder of random images then we're going to use to validate that the training went well and to calculate the accuracy of our neural network. That said, let's go to the terminal. Okay, so first we're going to download Pia. We have it now. Then we're going to download, where is it? The training images that I just showed you. Then we're going to unzip. We say all. Sorry. Okay. And then we're going to do, so where is it? We need to do a test folder. So you have to move things around in correct folder structures. And again, treat it like Zope. It has to be like this. Or if you're really annoyed, it's open source. You can fix it. And then we're going to also move, yeah. Let's move Pia into this test. Okay, so we have the training images and we have a photo of Pia. Okay, and then what we're going to do next is we're going to download a library that I found on the internet called VGG16PN. It doesn't really matter what it means, but for the sake of it, let's open it up. So that's the code. It's around 100 lines of code, I think. Yeah, 130. So there's a website called Kaggle. And Kaggle is a website where you have competitions, so data science competitions. So an organization will come on Kaggle and give, let's say, $100,000 award for improving one algorithm, and then engineers from around the world will compete. But from time to time, there are also like bragging rights competitions, which is they're not priced. But it's just for, if you win, you have bragging rights. And then the winner will also publish the code and their model. And a few years back, one of the winners was VGG, and it's still being used widely because it's a very simple model. It's fast. So this is what we're going to use now. So this is like a 150 lines of code that prepares VGG for us. It's on GitHub. You just use it. Okey-dokes. We have everything ready, so let's start with the demo. So yeah, this is I have, okay. So we import VGG. Oh, come on. Okay. and we instantiate it. Straight up Python. If you see any typos, please let me know. And then we're going to do batches. And we're going to say from training images, train folder, batch size equals 32. So when you train your model, you don't train it on all 2 or whatever 1,000 images you have, but in like small batches. And I chose 32 here because this is the highest number I can go without running out of memory. And then we can do the same for validation. Okay. We got it sorted out, and then we call vgg.finetune and give it batches. So what this does is VGG was trained, so the competition was called an ImageNet competition. ImageNet is 1.5 million of images, and then the task is to categorize them in 1,000 categories, right? So 1,000 categories, and but we're only interested in 2 categories, which is a cat or dog, not like 17 types of dogs. So what this does is basically it removes the last layer of the neural network that does categorization into 1,000 categories and replaces it with another layer, a new layer that just does categorization for 2 categories, right? And then we call fit, which is how you train. You give it batches, you give it validation batches. No, it's fine. And you say epoch 1. So epoch is 1 run over your training data. Normally you would do several runs and do it in random, so your training gets better, but we only have time for 1, so we're going to limit to 1. And then we say Pia is also, we're gonna use this get batches method. Get batches from the test folder that we created previously, and then because the API is not as nice, we have to do some wrangling around. Prediction is equals vgg.predict once the model has been trained, and then we can print and say Pia is a dot format, and then we do prediction, and again the output here is something a mathematician would expect, but not me, so there's a bit of wrangling around. And replace S with a empty string. So because we have the categories dogs and cats, and we're just going to remove the S at the end. So, and let's see how many typos I did. So when I started this Amazon instance, I used the deep learning AMI, so the deep learning Amazon machine image, which comes pre-installed with everything you need to do machine learning. And to use that, they use Anaconda, which is kind of like virtualenv. So basically, you just go into this Anaconda and use the Python that's there to run your code. All right, syntax error. Well, what I can do is I can do this. Oops, sorry. And then I can cheat and use a file that was pre-tested. So what this does is it spins up whatever it needs to spin up. It tells it it's using a GPU, which is what we want because this is what's going to make it fast. And then told us that it found 1,800 images, training images that belong to two classes, so two classes or two categories, which is dogs and cats. Then it found 170 images that it's going to use for validating how the training goes. And it started training. And if I do this, guys in the back can see it as well.
Category is taken from the folder name?
Yes. So that's the whole thing. Basically what you need to do here is wrangle your data and put it in the correct folders, and then just run it. So you need some time to figure out in which kind of tree structure this libraries expect the data to be, but once it's there, it's fine. So you could easily, we have cats and dogs, you could easily have like a house category, and it would just work out of the box. So we're about halfway through, 40 more seconds. Anyone has a joke for 30 seconds? So yeah, I really don't know math. I did high school math, but then university I was kind of getting along, but I'm really not good at math in any way. But I've been doing courses for deep learning for the last couple of months, and there's already a number of problems that I can solve with deep learning. So it's really approachable. It has become really approachable in the last years. And the funny thing is that even the data scientists that are building the algorithms don't really know what's going on under the hood. Because I think like recently Google did a new type of neural network, and it was really successful with this task of categorizing images, and they would write papers after papers after papers of the reason why it's so good is because it can go really deep. So everything was about the depth. And then somebody came by and then applied the similar principle with their model, but then just made it wide instead of deep, and it was even better. So that tells that even the experts building these networks don't really know and don't really understand what's going on behind the scenes. So don't be bothered if you don't understand everything. So yeah, here we see that the computer successfully tells us that Pia is in fact a dog. And that concludes our demo. And also, so our validation accuracy, which is running those 170 images against the neural network, gives us a 98.2% accuracy, which is fantastic. Even 3 years ago, if you would to get an 80% accuracy, you would need like $30,000 worth of equipment and weeks of training. And now in a few lines of Python in 2 minutes, you can get to 98% accuracy. So, yeah. Yeah, but how does this apply to Plone? I mean, it's well, well, I did some thinking, but not much. But we can have automated related items. This is a completely solved problem. When you have, you used to need hundreds and hundrds of related relations to be able to build a model for relations, but now you need maybe a couple hundred, but maybe even a couple 10 would be enough. It used to be all about big data, but we just trained a model with 2,000 images, which is nothing compared to what you would need 3 years ago. Automatic tags, recommendations. So recommendations, like the essence of Amazon is recommendations, and they publish their work. So you could do like, if you like this article, maybe you're going to like this one as well, based on what people liked before. You can do like malicious prevention, so predict traffic spikes. Obviously, there's if you have video and audio on your website, you can have automatic translation into text and maybe automatic translation into other languages. Plone is huge about multilingual. Why not provide the content author like pre-translated version of a certain content item, and then they just fix up just a couple of finishing touches. I'm sure that's much easier for the editor than it is to write everything from scratch. And you don't need to use Google Translate, but there are pre-trained models out there that you just download and start using. And And there's this huge talk about, which add-on is the best, let's get the best add-ons. It's, again, a problem completely applicable to deep learning. Another thing that I recently found is that the deep learning neural nets nowadays can describe you an image. So if you upload an image of 2 girls playing in a park, the output will be 2 girls playing in a park. So if you have a lot of images on your portal which don't have any caption, which is not very nice, you can again provide to whoever's uploading images a pre-generated caption of the image, and they just fix it up, or they just say, yeah, that's actually what the image is about. If you have a website where people are uploading cats and dogs, when they upload an image, you can ask them, it appears that this is a cat, would you like to categorize this as a cat, instead of they having to always select what it is. How to go, where to go from here, and just go here, course.fast.ai. It's a fantastic course. It's meant for coders, not for math majors. It's a 7-free-week online course. It's free, and you need about 10 hours per week, or you can just take 5 hours and then do it over 14 weeks. And after the first course, which is 2 hours, you already know how to do what we just did. And then every course you learn something. You learn about recommender systems. You learn about text summarization or text categorization. Every course is just mind-blowing. And their motto is making neural nets uncool again, because they're the people that do deep learning. They try. Probably not by intention, but they make it kind of elitic, and they just want, they make up new words and new jargon, and you come there and you're like, what is this? I will never learn this. But once somebody breaks that jargon down, you see it's very simple math, and most of the coders, or any coder, can understand and use it. Yeah, the code is there. You can find me on Twitter, and let's go to questions.